On a unit circle, we have previously seen that a point forming an angle of theta has cosine theta and sine theta as its coordinates. In this video, we are interested in graphing the function y equal to sine theta. Let's take the unit circle aside and bring in a coordinate system where the horizontal axis will represent the angle theta and the vertical axis the returned value of sine theta. For an angle of 0, there is no vertical displacement, then sine is 0. Then we plot the point 0, 0. For an angle of pi over 6, we have sine equal to half. Then we plot the point pi over 6 half. For an angle of pi over 4, sine is 1 over square root of 2. Then we plot the point pi over 4, 1 over square root of 2. For an angle of pi over 3, sine is square root 3 over 2, then we plot the point pi over 3 square root 3 over 2. Now an angle of pi over 2 gives sine equal to 1, then we plot the point pi over 2, 1. Now because of the symmetry of sine around pi over 2 over the interval 0 pi, we plot over the interval pi over 2 pi the points symmetrical to the points we've already drawn with respect to pi over 2. Now, opening the angle all the way to 3 pi over 2 gives sine equal to negative 1. Then we plot the points 3 pi over 2, negative 1. Going back to our starting point with an angle of 2 pi gives sine equal to 0, thus the point 2 pi 0. We can already see a curve forming. Joining the points gives this curve over 0, 2 pi. As sine has a period of 2 pi, then we complete the curve repeating it over every interval of length 2 pi in both directions. Then the graph of y equal to sine theta is this sinusoidal function repeating every interval of length 2 pi. Notice it is defined for all real numbers and it has a range from negative 1 to 1, then a maximum of 1 and a minimum of negative 1. We also notice that the curve is symmetrical with respect to the origin, then it is an odd function. As for the roots of the function, we notice that they all lie on multiples of pi, thus for theta equal to k pi, where k is an integer. The function repeats every interval of length 2 pi due to the period of the function being 2 pi. And notice the distance between the minimum and maximum points and the x-axis is 1 unit. That is referred to as the amplitude of the function. Now, can you, in a similar way, use the unit circle to draw the graph of y equal to cosine theta?